All right, good morning, guys. I'm going to show you how to create a linked list, but first, let's talk about what a linked list is. All right, as you can see, we have a linked list here, and what we have, this is the entire list, and then what we have here is nodes. So you have node 1, 2, 3, 4 here, right? If you look at this like a to-do list or a playlist of songs, etc. Think of like Pandora, where you can only go to the next song and not go back, because this is actually a singly linked list. If you're doing a doubly linked list, then you could go back, but we're only doing singly this video. So as you see here, all of the nodes are connected to each other, right? On a name of next. So next, a property is what I was looking for. Next. Okay. And so if we're looking here, the very first one is called the head, and the very last one is called the tail. You know it's the tail because next is going to point to null. So hopefully that makes sense. Okay, let's actually look over here on Visual Go or Visual Go, whatever they call it. Same thing here, right? So you've got a head here, and then each one is connected to the other, and then you've got the tail at the end, okay? Let's see what happens. Let's insert at the head something called, 85 is fine. As you can see, you got a new head here, right? And we'll talk about how to do that. Also, let's look at the big O complexity. So if we look at the access here, this is actually an array. I'm assuming that you know what an array is if you're looking at a linked list. If you don't know what it is, go back, check it out. But basically, when you want to access an item in an array, like this would be like one, actually zero, index of 0, 1, 2, 3, right? So if you wanted to access the third one, you could just do like array of 2, boom, and then you got that node, right? So you can't do that with a linked list, okay? So that's why the access here is O of 1 for an array. But then for a singly and doubly linked list, you got O of n. O of n meaning however many is in here, right? So let's just say if we want to look for the 43, we can't just say, okay, we want the linked list of 4, right? We'd have to, let's do a search for 43. When you want to access, when you go, boop, 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 boop. Okay. So it's like you have to go through each one because it's actually not indexed, okay? So let's actually go back here. So that's why we're looking at an O of n for here, and an array accesses faster, okay? But and then when you look at other things like even worst case scenario, insertion and deletion, it's much quicker than an array. And those are the reasons why you would use a linked list instead of an array, okay? You wanna look at all of these data structures like they're different tools for, different jobs, basically. Okay, and that's what a singly linked list is. In the next video, we'll cover what it looks like creating them.